Welcome to the Bedtime Lab, where we unravel the mysteries of the universe together, like old friends sharing secrets under a starlit sky. Tonight, we'll gently explore the enchanting world of red dwarf star systems. So, snuggle in and let your imagination drift among the stars. And as we begin this celestial journey, I'd love to know where you're watching from. Feel free to share in the comments. It's always a delight to hear from you. Now, let me paint a picture for you. Imagine the universe as a grand ballroom, where stars are the dancers twirling gracefully. Red dwarfs are the most numerous of these dancers, making up about 70% of all stars in our Milky Way galaxy. Can you imagine that? These subtle stars might not be the brightest, but they're certainly the most populous, quietly defining the rhythm of the cosmic dance. Speaking of their nature, did you know that red dwarf stars are the coolest stars in the universe? These stars have surface temperatures between 2,500 and 4,000 degrees Celsius. This cooler temperature gives them their characteristic reddish hue. Isn't it fascinating how the temperature of a star can influence its color? And here's something intriguing. Red dwarfs have incredibly long lifespans. Unlike their more massive counterparts that burn out quickly, red dwarfs can shine for tens of billions to even trillions of years. To give you a sense of scale, our own sun is expected to last about 10 billion years, a mere blink in comparison. Imagine the stories these stars could tell if they could speak. Now, let's wander a bit into the realm of planets. Many red dwarf stars are accompanied by rocky planets, some of which lie in the so-called habitable zone. This is the sweet spot where conditions might be right for liquid water to exist. Isn't it a delightful thought that these unassuming stars could host worlds where life might flourish? Here's another captivating thought. Because of their longevity and stability, red dwarfs provide ample time for life to potentially develop on their orbiting planets. Scientists often consider the age and stability of a star when pondering the possibility of life. In this sense, red dwarfs are quite the promising candidates. And speaking of life, did you know that planets orbiting red dwarfs are likely tidally locked? This means one side of the planet always faces the star, while the other remains in perpetual darkness. Imagine living on a world where the sun never sets on one side and never rises on the other. It's a climate of extremes, yet life could still find a way. Let me share something interesting about the activity of these stars. Red dwarfs often exhibit strong magnetic activity, resulting in spectacular stellar flares. These flares can be much more powerful than solar flares seen on our sun. It's a reminder that even the most unassuming stars can have a vibrant and occasionally tempestuous personality. Speaking of personalities, red dwarfs can be quite mysterious. Astronomers sometimes find it challenging to study these stars directly, because they are not particularly bright. They often rely on the planets orbiting these stars to glean more about them. The way planets move can reveal secrets about their stellar companions, like detectives piecing together clues. And here's a thought-provoking fact. Because they are so long-lived, red dwarf stars that formed early in the universe's history might still be shining today. They are like ancient storytellers from an era beyond our current understanding, weaving tales of the cosmos from eons past. Now let's consider the sheer abundance of these stars. While they are abundant, they are incredibly difficult to see with the naked eye from Earth. Their faint glow is often overshadowed by brighter stars, making them elusive to casual stargazers. Isn't it intriguing how something so common can go unnoticed? As we ponder these stars, imagine the countless civilizations that might exist around them, each with its own story. The universe is vast and full of possibilities, and red dwarfs are a significant part of that cosmic canvas. I hope this gentle journey through the world of red dwarf star systems has sparked your imagination and filled your mind with wonder as you prepare to drift into dreams. Remember, the universe is a vast, mysterious place, and there is always more to discover. Sleep well, my friend, and may your dreams be filled with stars. Let's delve deeper into the fascinating world of red dwarf star systems. You might be surprised to learn that despite their relatively small size, red dwarf stars can harbor immense gravitational influence. This is due to their density, which gives them a surprisingly strong gravitational pull for their size. It's a gentle reminder that sometimes the smallest stars hold the greatest power. Now, if you were to peer up at the night sky, you might find it difficult to spot a red dwarf with the naked eye. These stars, though numerous, are often dim and shy, hiding behind their brighter counterparts. Can you imagine a sky filled with stars that we can't even see? It's like a hidden world just waiting to be explored. Here's an intriguing tidbit. Red dwarf stars have a different way of generating energy compared to larger stars like our Sun. They burn fuel through a process known as hydrogen fusion in their cores, much like other stars. However, due to their low mass, they do this at a much slower rate, contributing to their incredibly long lifespans. This slow and steady approach means they might outlast many of the brighter stars we see shining in the night sky. Speaking of longevity, it's fascinating to consider that a red dwarf star born today could potentially outlive the universe as we know it. Their slow-burning nature means they could still be around when many other stars have ended their life cycles. Isn't it incredible to think of a star witnessing the universe's changes over trillions of years? And here's a cosmic curiosity. Red dwarfs are often surrounded by protoplanetary disks, which are clouds of gas and dust from which planets can form. This makes them excellent candidates for studying planet formation. In these swirling disks, you might find the building blocks of new worlds, slowly coming together under the gentle influence of the star's gravity. Have you ever considered what it might be like to live on a planet in a red dwarf system? The light from these stars is much different from the sunlight we're used to. It's a softer, redder light, casting a warm glow over everything. Imagine a sunset that never ends, bathing the landscape in a perpetual twilight. It's a poetic image that stirs the imagination, doesn't it? And speaking of imagination, here's a surprising fact. Red dwarfs can sometimes undergo dramatic changes in brightness due to their magnetic activity. These sudden flares can increase the star's brightness significantly for short periods. This variability is a fascinating puzzle for astronomers as they try to understand the underlying processes that cause such stellar gymnastics. One might wonder about the stability of solar systems around such flaring stars. Interestingly, despite these occasional outbursts, red dwarfs are remarkably stable over long periods. This stability provides a consistent energy source for any potential life forms on surrounding planets, offering a chance for life to adapt and thrive. Did you know that some of the closest stars to our solar system are red dwarfs? Take, for example, Proxima Centauri, the closest known star to the Sun. This red dwarf is part of the Alpha Centauri star system and serves as a nearby neighbor, sparking interest in its potential to host life-supporting planets. Another fascinating aspect of red dwarfs is their ability to form binary or even multi-star systems. In such systems, two or more stars orbit a common center of mass. These arrangements provide a unique dynamic where the gravitational interplay can lead to interesting orbital paths for any planets. Imagine living on a planet with 2 or more suns in the sky. As we contemplate these distant stars, it's worth noting that red dwarfs are incredibly efficient. They use their hydrogen fuel conservatively, so much so that they never undergo the dramatic transformations that larger stars do when they run out of fuel. Instead, red dwarfs quietly continue their slow burn, sometimes for trillions of years, until they simply cool and fade away. And here's a captivating thought. The vast majority of stars in our galaxy might be red dwarfs. Though they are difficult to observe, their sheer numbers make them a crucial component of the Milky Way. They are silent architects, shaping the structure and evolution of our galaxy over cosmic timescales. This reminds me of another interesting fact. Red dwarf stars can sometimes be found in globular clusters. These clusters are dense collections of stars bound together by gravity, providing a rich field of study for astronomers. Within these clusters, red dwarfs play a vital role in maintaining the delicate gravitational balance that holds the stars together. Finally, consider this. The cool temperature of red dwarf stars means they emit the bulk of their light in the infrared spectrum. This makes them particularly interesting for astronomers using infrared telescopes, revealing a universe that's invisible in regular visible light. It's as if red dwarfs speak a different language, one that we've only recently learned to understand and appreciate. As these gentle stars continue their quiet dance across the cosmos, they remind us of the beauty and mystery that lies beyond what we can see. Each red dwarf holds secrets of its own, waiting patiently to be uncovered by those curious enough to seek them out. Isn't it fascinating to think about how these unassuming stars hold so many secrets? Let me share another intriguing detail about red dwarf stars. They are known for their incredible magnetic fields. Despite their small size, these stars can possess a magnetic field that is several times stronger than that of our Sun. This intense magnetism is due to the turbulent motions within their interiors, stirring up charged particles and contributing to the flares and activity we mentioned earlier. It's a reminder of how even the smallest stars can pack quite a punch. Speaking of magnetic activity, this often leads to a phenomenon known as star spots. Much like sunspots on our own star, these cooler, darker regions on the surface of red dwarfs are areas where the magnetic field is particularly strong. However, on red dwarfs, these spots can cover a much larger portion of the star, sometimes dominating its surface entirely. Can you imagine the sight of a star with a patchy, mottled appearance, its light flickering gently as these spots shift and change over time? Let's turn our attention to the life of a red dwarf. While they may have a slow and steady burn, red dwarfs go through a remarkable evolutionary journey. As they age, they slowly increase in brightness, a process that takes billions upon billions of years. This gradual brightening is so subtle that it's almost imperceptible over human timescales, yet it fundamentally transforms the star over the eons. It's a cosmic reminder of the slow, inevitable march of time. Now, here's something to ponder. The planets around red dwarf stars may be significantly different from those in our solar system. Because red dwarfs are much cooler, their habitable zones, or the regions where liquid water could exist, are much closer to the star. This proximity means that planets there might be tidally locked, with one side perpetually facing the star and the other cloaked in darkness. Imagine the unique climates and cycles of day and night such planets might experience. Continuing on this thread, the habitable zones around red dwarfs might be promising places to search for signs of life. Their longevity means that any potential life forms would have a vast expanse of time to evolve and adapt. Some scientists even speculate that red dwarf systems could be ideal cradles for life forms that thrive under conditions vastly different from our own. Isn't it exciting to think about the potential diversity of life beyond our familiar earthly bounds? As we explore further, consider that red dwarf stars are also known for their ability to retain their outer layers. Unlike larger stars, which shed their outer material as they age, red dwarfs hold on to their outer layers throughout their incredibly long lifespans. This retention helps maintain a relatively consistent energy output, providing stable conditions for any orbiting planets. This stability could be a key factor in the sustainability of life, should it exist there. Another captivating aspect is the variability of red dwarf systems. Due to their magnetic activity, some red dwarfs exhibit frequent and intense flaring. These flares can emit powerful bursts of ultraviolet and X-ray radiation that may challenge the survival of life on nearby planets. It's a cosmic dance between stability and upheaval, a delicate balance that shapes the environment of these stellar systems. Speaking of environments, it's quite fascinating to consider how the light from a red dwarf might affect the appearance of its surrounding planets. The soft, reddish hue could influence plant life, should it exist, leading to unique adaptations. Some theorize that vegetation might not be green, as on Earth, but could instead exhibit hues of red, black, or even silver to make the most of the available light. Just imagine a world where the flora paint the landscape in colors beyond our current experience. And here's another surprising fact. Red dwarf stars are among the best places to search for exoplanets using a technique known as the transit method. When a planet passes in front of its star, it causes a slight dimming of the star's light. This method is particularly effective with red dwarfs, as their smaller size means even small planets can cause noticeable dips in brightness. It's a testament to how even the faintest stars can reveal hidden treasures. Let's not forget the role of red dwarfs in the broader cosmos. These stars are thought to be the most numerous in the universe, making up the bulk of the stellar population in our galaxy. Their abundance ensures they play a critical role in galactic dynamics and evolution, serving as a constant backdrop to the more dramatic life cycles of larger stars. It's a humbling thought, isn't it? As we continue to unravel the mysteries of these stars, remember the importance of perseverance in astronomical research. The seemingly quiet and unchanging nature of red dwarfs masks a complex and dynamic world. By studying them, we unlock new understandings of the universe and our place within it. Each observation, each discovery, adds another piece to the cosmic puzzle, inviting us to look beyond what we know and imagine what might be. Imagine a universe where the smallest stars command the spotlight. One fascinating detail about red dwarf stars is how their size and mass influence their life cycles. Due to their modest mass, red dwarfs burn their hydrogen fuel slowly and efficiently, which leads to remarkably long lifespans. These stars can live for tens of billions, even trillions of years. In fact, no red dwarf has yet reached the end of its life cycle within the current age of the universe. This longevity is a stark contrast to massive stars that live fast and die young, often in spectacular explosions. Here's an intriguing thought. The cores of red dwarf stars remain fully convective throughout their lives. This means that the material in the core is constantly being mixed, preventing the buildup of helium ash, which is a byproduct of nuclear fusion. This constant mixing allows red dwarfs to use nearly all of their hydrogen fuel, unlike larger stars that exhaust their core fuel and leave behind helium-rich cores. It's as though these stars have mastered a kind of cosmic efficiency, making the most of what they have. Let me tell you something remarkable about these stars and their atmospheres. The atmospheres of red dwarfs are often dominated by molecules, including water vapor, carbon dioxide, and even titanium oxide. This molecular richness can result in a variety of spectral signatures, offering a kaleidoscope of information to astronomers studying them. It's almost as if each star carries a unique fingerprint, a complex blend of elements telling the story of its environment. Did you know that red dwarfs are often much cooler than our own Sun? Their surface temperatures can range from 2,500 to about 4,000 degrees Celsius, compared to the Sun's surface temperature of approximately 5,500 degrees Celsius. This cooler temperature contributes to their reddish appearance, as cooler stars emit more light at longer, redder wavelengths. It's a vivid reminder of how temperature can influence the perception and understanding of celestial bodies. Speaking of perception, think about how red dwarf stars are often less luminous than larger stars, making them appear much fainter in the night sky. Despite their abundance, they are not frequently visible to the naked eye. It's a paradox of sorts. The most numerous stars are often some of the hardest to see without telescopic aid. This quiet presence underscores the vastness and diversity of our universe, reminding us that not everything that's significant is immediately visible. Another interesting aspect is how red dwarfs tend to have lower metallicity compared to stars like the Sun. Metallicity in astronomy refers to the presence of elements heavier than hydrogen and helium. This lower metallicity can impact the formation of planets around red dwarfs, possibly influencing the types and compositions of planets that can form in these systems. It adds another layer of complexity to the study of planets beyond our solar system, highlighting the intricate dance between stars and their planetary companions. Red dwarfs also host fascinating magnetic phenomena. Their magnetic fields can be incredibly strong, leading to surface activities that are both intense and varied. These fields can influence the surrounding space environment, affecting any orbiting planets with solar winds and flares. Imagine the impact of such powerful magnetic activity on a planet's atmosphere and potential habitability. It's a dynamic interplay between the star and its planetary family, shaping the conditions for any potential life. You might find it interesting that red dwarfs are excellent targets for detecting exoplanets, particularly Earth-sized ones. Their smaller size means that the gravitational influence of a planet is more pronounced, making it easier to spot wobbles in the star's position. This has made red dwarfs prime targets in the search for worlds beyond our solar system, contributing significantly to our understanding of the potential for life elsewhere in the universe. Let's consider the role of red dwarfs in ancient mythologies. Although they are faint to the naked eye, their subtle presence has woven its way into the folklore of various cultures, often symbolizing the unseen forces of patience and persistence. It's fascinating to reflect on how these stars, through their timelessness, have captured the human imagination and inspired stories passed down through generations. And here's another thought. The study of red dwarfs provides a window into the early universe. Since these stars can survive for so long, they offer clues about the conditions and processes that occurred shortly after the universe's formation. By examining ancient red dwarfs, astronomers can piece together a historical timeline of cosmic evolution, shedding light on how galaxies and stars have changed over billions of years. Think about how red dwarfs challenge our understanding of where life might thrive. The unique conditions within these systems, such as their long lifespans, varying magnetic activity, and different lighting environments, pose intriguing questions about the adaptability and resilience of life. Each discovery pushes the boundaries of what we know, encouraging us to look beyond our earthly experience and imagine new possibilities in the cosmos. The exploration of red dwarf systems is a journey through time and space, revealing the subtle, intricate wonders of the universe. Each star, each planet, each observation becomes a piece of a grander puzzle, inviting curiosity and wonder at the endless possibilities that lie among the stars. Let me share another intriguing aspect of red dwarf star systems with you. The planets orbiting these stars often lie within a zone known as the habitable zone, where conditions might be just right for liquid water to exist. This zone is much closer to red dwarfs than it is around stars like our Sun due to their cooler temperatures. Can you picture a planet tucked comfortably within this zone, possibly harboring the essential ingredient for life? It's a captivating thought that fuels our exploration of these distant worlds. Speaking of planets, did you know that tidally locked planets are more common around red dwarfs? This means that one side of the planet always faces the star, while the other side remains in perpetual darkness. Imagine standing on such a planet where the star never rises or sets, casting a permanent day or night. This unusual phenomenon raises fascinating questions about the climate and potential habitability of these worlds, as one side might be scorching hot while the other is frigidly cold. Here's something else that might surprise you. Red dwarfs can exhibit intense flaring activity. Despite their relatively low energy output compared to larger stars, they can unleash powerful solar flares that dwarf those of our Sun. These flares can dramatically increase the star's brightness for short periods and have a significant impact on nearby planets, potentially stripping away atmospheres or altering climates. It's a reminder of the volatile nature of these seemingly quiet stars. Red dwarfs also boast an impressive longevity, often living for trillions of years. This is far longer than any other type of star, offering a stable environment for planets over extended periods, more than the current age of the universe. Just imagine the rich history a planet orbiting such a star might have, with eons of time to develop and evolve. Let's consider their distribution in the galaxy. Red dwarfs are the most common type of star in the Milky Way, making up about 70 to 80% of all stars. This abundance means that statistically, if you were to point in any direction in the galaxy, you would likely be pointing toward a red dwarf. Their ubiquity highlights their importance in the cosmic landscape and our quest to understand the universe. Interestingly, some red dwarfs are found in binary or multiple star systems, orbiting alongside other stars. This proximity can lead to intriguing gravitational interactions, affecting the orbits of any planets and creating a dynamic celestial dance. Picture a world where the sky is graced not just by one sun, but perhaps two or even three, each bringing its own rhythm to the day-night cycle. Another fascinating feature of red dwarfs is their ability to remain in the main sequence phase for extraordinarily long periods. While our Sun is destined to evolve into a red giant in a relatively short 5 billion years, a red dwarf can stay stable for hundreds of billions to trillions of years. This prolonged phase gives scientists a unique opportunity to study stellar evolution over a cosmic timescale. Have you ever wondered about the potential for life in these star systems? The long lifespan of red dwarfs, coupled with the stability of their habitable zones, offers tantalizing possibilities for life to develop and thrive. Although the conditions might be quite different from those on Earth, the sheer abundance of red dwarfs increases the odds of finding life elsewhere in the universe. Let me tell you about the variability in brightness that some red dwarfs exhibit. Known as flare stars, These red dwarfs can suddenly increase in brightness due to magnetic activity. This variability can be both a challenge and an opportunity for astronomers, as it requires careful observation to distinguish between the star's natural variability and any potential planetary transits. And here's something to ponder. Red dwarfs can form from relatively low-mass clouds of gas and dust. This means that even in regions where star formation is not as vigorous, red dwarfs can still emerge, quietly populating the universe. Their ability to form in a variety of environments underscores their adaptability and prevalence. Another remarkable fact is that the smallest known stars are actually red dwarfs. These diminutive stars, at the low end of the mass spectrum, are just large enough to sustain nuclear fusion in their cores. Despite their size, they share the same fundamental processes as larger stars, a humbling reminder of the vast range of scales on which the universe operates. Finally, did you know that studying red dwarfs can also help us understand the past of more massive stars? Since red dwarfs evolve so slowly, they provide a snapshot of the early conditions in which more massive stars once existed. By examining these small stars, astronomers can glean insights into the early life cycles of their larger counterparts, piecing together the history of stellar evolution across the galaxy. As you drift into restful contemplation, consider how these quiet yet powerful stars continue to inspire us, revealing the mysteries of the cosmos with each new discovery. Speaking of the mysteries these stars unveil, did you know that red dwarfs, despite their small size, have a rather remarkable influence on their surroundings? Their gravitational pull, though weaker than that of larger stars, is still potent enough to shepherd clusters of debris and dust, potentially leading to the formation of new planets over eons. Envision a slow-motion ballet where cosmic dust gathers, coalescing into nascent worlds under the watchful eye of a red dwarf star. Here's an intriguing thought. The habitable zone of a red dwarf star is not only closer, but can also shift over time due to the star's gradual increase in luminosity. As the star ages, its habitable zone can move outward, potentially allowing planets previously too cold to become warm enough for liquid water. Imagine a world gradually coming to life as its orbit takes it into the golden embrace of its star's warmth. Now, consider this. Red dwarfs spin on their axes at varying speeds, often much faster when they are young. This rotation rate can cause intense magnetic fields that, in turn, generate those powerful flares we touched upon earlier. The idea of a young red dwarf spinning like a cosmic top, throwing off bursts of energy, paints a picture of a dynamic, youthful universe full of energy and change. Have I mentioned how red dwarfs can also serve as valuable cosmic timekeepers? Because of their incredibly slow evolution, they offer a sort of galactic clock to astronomers. By studying red dwarfs of different ages, scientists can trace back the history of our galaxy, gaining insights into the processes that have shaped it over billions of years. And here's something you might find surprising. Many red dwarfs are located in globular clusters, ancient collections of stars tightly bound by gravity. These clusters, some of the oldest structures in the universe, provide an environment rich in history, where red dwarfs have been stable for billions of years. Can you imagine the stories these stars could tell of the cosmic dances and gravitational interactions they've witnessed over such immense timescales? Speaking of stars, did you know that some red dwarfs have surprisingly high metallicity, meaning they contain a greater proportion of elements heavier than hydrogen and helium? This richness in heavier elements suggests that these stars formed in regions where previous generations of stars enrich the interstellar medium with the remnants of their own life cycles. Here's a curious fact. Red dwarfs sometimes have what is known as star spots, akin to sunspots on our sun, but often much larger and more persistent. These cooler, darker regions on the star's surface can affect its brightness and provide clues about the star's magnetic activity. Imagine observing a red dwarf over time, watching as these spots shift and change, offering a window into the star's inner workings. Speaking of inner workings, another fascinating aspect of red dwarfs is their internal structure. Unlike larger stars, red dwarfs are fully convective, meaning the material within them circulates from the core to the surface. This constant churning ensures a uniform composition throughout the star's life, a feature that sets them apart from their more stratified stellar siblings. And did you know that because of their lower temperatures, red dwarfs emit most of their light in the infrared spectrum? This unique characteristic allows astronomers to study them using specialized infrared telescopes, which can peer into dusty regions of space where visible light is obscured. It's like having a special pair of glasses that reveal hidden dimensions of the universe. Here's another captivating notion. Some red dwarfs have been discovered to host planets with extreme climates, where winds might blow at incredible speeds due to the temperature differences between their day and night sides. Imagine standing on such a planet, feeling the rush of powerful gales shaped by the rhythmic dance of light and shadow. Transitioning to another point, red dwarfs often serve as cosmic laboratories where the physics of low-mass stars is tested and refined. By studying their properties, scientists can develop models that help predict the behavior of stars across different masses and environments. It's like having a miniature cosmic workshop where theories are crafted and tested against the backdrop of the universe. Finally, let's ponder on the thought that red dwarfs may play a crucial role in the search for extraterrestrial life. Their prevalence and longevity make them prime targets for missions seeking Earth-like planets. The quiet persistence of these stars, coupled with their stable environments, provides a promising backdrop against which the search for life beyond Earth can unfold. As you reflect on these wondrous facts, let your mind wander to the boundless possibilities that red dwarf star systems offer. In the vast expanse of space, these small but mighty stars continue to illuminate the path of exploration and discovery, whispering secrets of the cosmos to those who listen closely. As you continue to relax and let your imagination drift through the cosmos, consider the intriguing notion that red dwarfs can sometimes have companions. Yes, these stars often exist in binary or even trinary systems, where 2 or 3 stars orbit a common center of mass. It's like a celestial dance where these stars are locked in a gravitational embrace, each influencing the other in a delicate balance. And here's something you might not expect. In some of these multi-star systems, the gravitational interactions can lead to the creation of exoplanetary orbits that are exotic and complex, with planets sometimes experiencing lighting conditions that change dramatically as they orbit not just one, but multiple suns. Picture a planet where the sky shifts in color and brightness as different stars dominate the skyline, a place where day and night are painted with a palette of celestial hues. Speaking of planets, did you know that the slow nuclear fusion processes within red dwarfs allow them to maintain their energy and stability for trillions of years? Their longevity far exceeds that of more massive stars, providing a steady source of warmth and light for any accompanying planets over unfathomable timescales. Imagine a cosmic clock ticking ever so slowly, marking eons with the soft glow of a red dwarf. This leads us to another fascinating insight. Because of their prolonged lifespans, Red dwarfs offer a unique perspective on the potential for life elsewhere in the universe. The stable environments they create could give rise to life forms that have evolved over incredibly long periods, adapting to the peculiarities of a red dwarf's light and heat. Imagine the diversity of life that could emerge under such conditions, each species finely tuned to the rhythm of its stellar host. And while we're on the subject of adaptation, here's an interesting twist. Red dwarfs, with their cooler temperatures, allow planets to orbit much closer than those around hotter stars. This proximity could mean that even small planets have enough gravitational pull to retain an atmosphere, potentially supporting life in conditions vastly different from those we know. Can you envision a world where lush landscapes are nurtured in the gentle and constant glow of their diminutive star? Now let's delve into the subtlety of their appearances. Red dwarfs, despite being the most common stars in the Milky Way, are often too faint to be observed without a telescope. Their dim light blends seamlessly into the night sky, making them elusive yet abundant treasures for astronomers. This abundance suggests that the universe may be teeming with red dwarf systems, each a potential cradle for new planetary discoveries. In the quiet vastness of space, red dwarfs also exhibit a remarkable constancy, maintaining their brightness with minimal fluctuations. This stability makes them excellent reference points for measuring the movement of other celestial objects, providing astronomers with tools to map the intricate dance of stars and galaxies. It's as though these stars hold the keys to unlocking the secrets of cosmic motion, silently anchoring the celestial sphere. Speaking of secrets, did you know that some red dwarfs possess flaring activity so intense that it can strip away the atmosphere of nearby planets? These powerful flares release bursts of radiation, posing challenges for any potential life clinging to the surface of orbiting worlds. Yet, over millennia, this harsh environment could also drive evolutionary changes, fostering resilience and adaptation in life forms that survive such extremes. It's curious to note that despite their abundance, red dwarfs have only recently become a focal point in the search for exoplanets. With advances in technology and observation techniques, scientists have begun to uncover a myriad of planets orbiting these stars, each discovery adding a piece to the puzzle of our cosmic neighborhood. It's like finding hidden gems scattered across the galactic landscape, each one offering tantalizing hints about the diversity of planetary systems. And here's a truly unexpected tidbit. Some red dwarfs may never fully cease their fusion processes. While larger stars eventually exhaust their fuel and evolve into white dwarfs or explode in supernovae, red dwarfs burn so slowly that they could continue fusing hydrogen for longer than the current age of the universe. Imagine a star that persists through seemingly endless epochs, a beacon of continuity in the ever-changing cosmos. Lastly, consider the prospect that in the distant future, as larger stars phase out and the universe cools, red dwarfs might become the primary sources of light and heat. This transformation would usher in an era dominated by these unassuming stars, where life, if it exists, would need to adapt to their gentle, pervasive glow. It's a vision of a future universe painted in soft hues where the legacy of red dwarfs endures long after other stars have faded away. Let me take you on a journey deeper into the world of red dwarf star systems, revealing facets that, at first glance, might not be so obvious. Did you know that the atmospheres of red dwarfs can be incredibly complex? These stars often have turbulent layers where convective processes mix their internal material, creating a surface that is constantly in motion. This churning atmosphere is quite unlike our Sun, where such mixing occurs primarily in the outer layers. It's a dynamic environment, one that belies the calm appearance of these stars from afar. Here's something that might surprise you. Red dwarfs can have magnetic fields that are quite powerful. Despite their small size, these magnetic fields can rival those of larger stars. This magnetic activity can manifest as star spots, dark, cooler regions on the star's surface where magnetic activity is intense. These star spots can cover a substantial portion of the star, and their presence is a testament to the inner vigor of these seemingly quiet stars. Imagine a star with a constantly shifting landscape of dark patches, a sunspot-dotted world that never appears quite the same from one moment to the next. On the subject of variability, did you know that red dwarfs can exhibit significant changes in brightness due to their magnetic activity? While they are generally stable, when these magnetic processes become particularly active, the resulting flares can cause the star's brightness to fluctuate noticeably. These variations, although brief, can be astonishingly intense, dramatically altering the perceived light output of the star for those observing from afar. Let's consider another intriguing possibility, the presence of water worlds orbiting red dwarfs. Because planets can reside close to these stars without being scorched, they might host liquid water on their surfaces. These planets, sometimes referred to as ocean worlds, could be shrouded in vast seas, offering yet another potential habitat for life. It's fascinating to ponder entire planets covered in water, gently illuminated by the persistent glow of a red dwarf, a serene contrast to the often harsh environments found elsewhere in the galaxy. And speaking of planetary conditions, you might be surprised to learn that the habitable zones around red dwarfs are relatively narrow. This means that planets need to maintain a delicate balance to support liquid water, as they cannot afford to drift too far from their host star. Such tight constraints could lead to unique evolutionary paths for any life that might develop there. Life that must be remarkably adaptable to survive in what could be considered a precariously balanced ecological niche. Here's a thought-provoking notion. The longevity of red dwarf stars allows them to witness the rise and fall of civilizations on their planets, should they exist. Over time frames that stretch beyond human comprehension, entire histories could unfold under the watchful gaze of a red dwarf, its steady light a silent observer of the dramas playing out on worlds orbiting within its gravitational grasp. Imagine the stories these stars could tell, if only they could speak. Did you ever wonder why red dwarfs are so faint? Their dimness is primarily due to their smaller size and the cooler temperatures of their surfaces. This coolness in turn means they emit less light. Yet, despite their faintness, these stars are incredibly numerous. So prevalent, in fact, that they make up about 70% of all stars in the Milky Way. This abundance means that while individual red dwarfs might be hard to spot, collectively, they constitute the backbone of our galaxy's stellar population. Here's an intriguing fact about their energy efficiency. Red dwarfs convert hydrogen into helium at a leisurely pace compared to larger stars. This slow and steady fusion process is what grants them their longevity. It's as if they are conserving their fuel, ensuring they remain luminous for the longest possible duration. This efficiency could also mean that as the universe ages, red dwarfs will continue to shine long after other stars have expended their nuclear fuel and faded into obscurity. Now, let me share a little-known aspect of red dwarf systems. Their planets, if they do exist, often have synchronous rotations. This means one side of the planet always faces the star, while the other side remains in perpetual darkness, a situation known as tidal locking. This creates stark contrasts in climate and temperature between the two hemispheres. potentially leading to fascinating meteorological phenomena. Picture a world where one side basks under constant daylight while the other side languishes in eternal night, a planetary yin and yang sculpted by the gravitational embrace of its host star. Finally, consider the idea that the future of astronomical research may hinge on the study of these unassuming stars. As our technology advances and we uncover more about red dwarfs and their planets, we may find that they hold vital clues to understanding the formation and evolution of the galaxy. Their ubiquity and stability make them ideal subjects for studying not just stellar processes, but also the intricate web of life that might exist beyond our solar system. Imagine the possibilities that lie in unraveling the mysteries of these quiet, yet fascinating denizens of the cosmos. Let me take you further into the mysterious world of red dwarf star systems, revealing some surprising aspects you might not have considered. To start, did you know that red dwarf stars are not only numerous but also very diverse in their compositions? These stars can have varying amounts of elements heavier than hydrogen and helium, known in astronomy as metals, which can affect their evolution and the types of planets that form around them. This diversity means that no two red dwarf systems are exactly alike, each one offering its own unique set of conditions and potential surprises. Speaking of planetary systems, have you ever pondered how many planets might orbit a red dwarf? Due to their smaller size and cooler nature, red dwarfs can host planets very close to them without those planets becoming inhospitable. Some red dwarfs have been found to host numerous planets, often tightly packed within what would be a very cramped neighborhood by our solar system's standards. These compact systems can exhibit complex gravitational interactions, leading to intriguing orbital dynamics. Here's a fascinating detail you might not expect. Red dwarf stars can occasionally emit powerful flares that are much larger relative to their size than those observed on our Sun. These flares can release enormous amounts of energy and radiation, which could have significant implications for any nearby planets and their potential to support life. Imagine a sudden burst of activity that temporarily alters the conditions on a planet's surface, presenting a formidable challenge for life forms trying to adapt to such extremes. Now, consider this about red dwarf stars. They are often surrounded by a dense region of stellar debris. This material, left over from the star formation process, can include dust and gas that might eventually coalesce into new planets or moons. The presence of this debris could influence the early development of planetary systems, offering a glimpse into the primordial chaos that leads to the birth of new worlds. Transitioning from star formation to star death, did you realize that red dwarfs, due to their slow burn-in nature, will never explode as supernovae? Instead, they end their lives in a much quieter fashion, simply running out of fuel and slowly cooling into a white dwarf over trillions of years. This gradual death means that red dwarfs have the potential to exist for an incredibly long time, far outlasting more massive stars that live fast and die young. On the topic of longevity, did you know that the oldest known red dwarfs are nearly as old as the universe itself? These ancient stars have witnessed cosmic events that are almost beyond our imagination, from the formation of galaxies to the birth of countless stars and planets. As silent sentinels, they hold the secrets of the universe's history within their dim light, a living link to a time when the cosmos was still in its infancy. Turning back to planetary phenomena, let me tell you about the potential for auroras on planets orbiting red dwarfs. If these planets have magnetic fields, they could experience spectacular displays of light in their skies, akin to the northern and southern lights on Earth. Such auroras would be driven by the magnetic activity of the red dwarf itself, adding another layer of wonder to the already intriguing atmospheric dynamics of these planets. Here's a thought-provoking notion. The sheer abundance of red dwarfs means that statistically, many of the stars nearest to us in the galaxy are likely to be red dwarfs. This abundance increases the likelihood of finding red dwarf systems that are relatively close by, making them prime targets for future exploration and study by astronomers hoping to uncover their secrets. Have you ever imagined what the sky might look like from a planet orbiting a red dwarf? Due to the star's dimness and red hue, the daytime sky could appear dramatically different from Earth's, perhaps bathed in deep reds and oranges, or even reminiscent of a permanent twilight. This altered color palette could have significant effects on the biology of any native life forms, potentially influencing everything from photosynthesis to visual perception. Switching gears, let's explore the fascinating concept of super-Earths that might orbit red dwarfs. These planets, larger than Earth but smaller than the ice giants in our solar system, could offer stable environments for life, particularly if they reside in the habitable zone. The gravitational pull of a red dwarf could lead to thicker atmospheres on these planets, which might help moderate temperatures and shield life from harmful radiation. Don't forget the intriguing idea that planets in red dwarf systems could be in resonant orbits. This means they may have synchronized rotations and revolutions with other planets, creating a cosmic dance of sorts. Such synchronization could help stabilize the planet's orbits over long periods, providing a consistent environment for any life that might evolve there. Imagine the implications of finding organic molecules in the atmospheres of planets orbiting red dwarfs. The presence of these building blocks of life could indicate that the conditions necessary for life might be more common than we previously thought, especially in these abundant and long-lived star systems. Here's a surprising consideration. Despite their immense pressure, the cores of red dwarfs are relatively cool compared to larger stars. This means the fusion processes that occur within them are more efficient, allowing for a prolonged life cycle and steady energy output over trillions of years. This internal efficiency highlights the remarkable balance within these stars, where energy production is finely tuned to their size and mass. Lastly, consider the role of red dwarfs in the future of our galaxy. As other stars burn out, red dwarfs will continue to illuminate the cosmos, becoming more prominent as time goes on. Their endurance and stability could make them the last beacons of light in a distant future, a testament to the quiet power of these unassuming stars. As we peer into the night sky, it's humbling to think of the countless red dwarfs twinkling in the darkness, each with its own story and potential for discovery. Imagine a universe teeming with life, its origins tied to the stars themselves. Red dwarf stars, those seemingly quiet and unassuming celestial objects, might just hold the key to unlocking the secrets of life's widespread existence. Did you know that red dwarfs make up nearly 75% of all stars in the Milky Way? This overwhelming majority suggests that planets orbiting red dwarfs could be abundant, increasing the odds of discovering life beyond our solar system. Yet, despite their abundance, red dwarfs are notoriously difficult to observe with the naked eye due to their dim nature, presenting a unique challenge for astronomers eager to study them. Speaking of challenges, have you ever wondered about the climates of planets orbiting these stars? With their typically smaller habitable zones, red dwarf planets might experience more extreme weather patterns than those of Earth. Changes in the star's radiation output could lead to fluctuating climates where rapid temperature shifts occur. This dynamic environment might actually encourage adaptability in potential life forms, fostering resilience in ways we might not initially expect. Now, here's something intriguing. Red dwarfs often host planets that are tidally locked, meaning one side of the planet perpetually faces the star while the other remains in darkness. Can you imagine such a world? The dichotomy between day and night sides creates a stark contrast where one hemisphere might be scorching hot and the other icy cold, with a narrow band of temperate conditions in between. This twilight zone could harbor unique ecosystems adapted to straddle the light and dark. Another fascinating aspect of red dwarfs is their potential to host eyeball planets. These are planets with water, where the star-facing side could have a large liquid ocean surrounded by ice, resembling an eye when viewed from space. Such planets could provide stable environments for marine life, with the ocean maintaining a steady temperature due to the star's heat. You might be surprised to learn that red dwarf stars have a peculiar way of recycling their own material. Unlike larger stars, which tend to develop layers that prevent mixing, red dwarfs fully convect, meaning they stir their hydrogen and helium throughout their entire volume. This efficient mixing enables them to burn their fuel more completely, contributing to their impressively long lifespans. Considering their longevity, red dwarfs will be among the last shining stars in the universe. As other stars extinguish their light, these resilient stars will continue to illuminate the cosmos, potentially supporting life for trillions of years. Their endurance offers a glimpse into the distant future of our galaxy, where red dwarfs will become the primary sources of starlight in an aging universe. Let's delve into the magnetic personalities of these stars. Red dwarfs can possess strong magnetic fields, often leading to heightened stellar activity. This characteristic can result in intense stellar flares that, while potentially hostile to life, also play a role in shaping their surrounding space environments. These magnetic fields could influence the atmospheres of orbiting planets, impacting everything from weather patterns to potential auroral displays. Speaking of auroras, did you know that the intense magnetic activity of red dwarfs might actually strip away the atmospheres of nearby planets? This process, known as atmospheric escape, could dramatically shape the evolutionary path of these planets, determining whether they become barren rocks or hospitable havens. Yet planets with strong magnetic fields of their own might resist this stripping, preserving their atmospheres and increasing the odds for life. One might wonder how these stars can be so active, yet remain relatively stable over time. The answer lies in their gradual nature. Unlike more massive stars that exhaust their fuel rapidly, red dwarfs burn slowly, maintaining a stable energy output over trillions of years. This slow burn provides a consistent environment for any potential life forms, allowing ample time for life to adapt and evolve. And speaking of evolution, red dwarfs might be more forgiving of planetary atmospheres than previously thought. While intense flares could threaten habitability, the long periods of relative calm between these events might offer just enough stability for life to thrive. In this way, red dwarfs demonstrate their dual nature, both formidable and nurturing, challenging life to adapt while simultaneously providing a consistent backdrop for evolution. Have you ever considered the potential for moons orbiting planets in red dwarf systems? These moons could harbor their own unique environments, possibly hosting subsurface oceans warmed by tidal heating or geothermal activity. Such moons, with their protected liquid water, could offer ideal conditions for microbial life or even more complex organisms to develop and persist. Furthermore, red dwarf systems could include planets with thick, insulating atmospheres that help retain heat even in the absence of direct sunlight on tidally locked worlds. This greenhouse effect might create stable conditions for life in the twilight zones of these planets, where perpetual dusk offers a constant, albeit dim, source of energy. To add another layer of intrigue, imagine the possibility of life on rogue planets ejected from red dwarf systems. These planets, drifting through interstellar space, might still maintain internal heat or subsurface oceans, providing isolated environments for life to exist away from any star's influence. Finally, consider how the migration of planets within red dwarf systems could impact their habitability. As planets shift position over time, they might move into more favorable or less hospitable regions, experiencing varying degrees of stellar radiation and gravitational forces. This orbital dance, while chaotic, could offer new opportunities for life to emerge in places where it might not have been possible before. Imagine this: red dwarf stars, despite their diminutive size, actually make up the majority of stars in our galaxy. Isn't it fascinating to think that these unassuming stars outnumber more prominent stars like our Sun? In fact, it's estimated that about 75% of stars in the Milky Way are red dwarfs. This prevalence means that the chances of finding habitable planets orbiting these stars could be higher than we once thought. Here's a curious tidbit. Red dwarfs are sometimes referred to as M-type stars in the astronomical classification system. This classification helps scientists understand their size, temperature, and brightness. These stars are cooler than the Sun, with surface temperatures ranging from around 2,500 to 4,000 Kelvin. Because of their cooler nature, they emit light primarily in the red and infrared spectrum, giving them their characteristic glow. Did you know that red dwarfs can vary significantly in terms of activity? Some are relatively quiet, while others can be extremely active, with frequent and powerful flares that can outshine the star itself for short periods. These energetic outbursts can release vast amounts of radiation, which might sterilize nearby planets or, conversely, drive evolutionary processes by forcing life to adapt to harsh conditions. Speaking of adaptation, consider the ways in which planetary systems around red dwarfs might differ from those around larger stars. Because red dwarfs have lower luminosity, their habitable zones are much closer to the star. Planets residing in these zones could have shorter orbital periods, possibly resulting in faster evolutionary cycles. It's intriguing to think about how life might evolve differently under such conditions. Another delightful fact is that red dwarf stars can take trillions of years to fully burn through their hydrogen fuel. This immense longevity compared to stars like the Sun means they provide a stable and persistent energy source for any surrounding planets. Imagine the possibilities for life to thrive over such extended timescales. It's truly a testament to the enduring nature of these stellar bodies. Now, here's a thought-provoking scenario. Since red dwarfs are ubiquitous and long-lived, they could serve as cosmic markers for locating planets with potential life. With advancements in technology, astronomers might one day pinpoint the most promising systems for exploration and study, guided by the stable light of these stars. In addition to their abundance, red dwarfs are also among the oldest stars in the galaxy. Some are nearly as old as the universe itself, having formed shortly after the Big Bang. This ancient lineage provides a unique window into the early history of the cosmos, revealing the evolution of stars and their potential to host life over billions of years. You might find it surprising to learn that red dwarfs are also capable of forming multi-star systems. While we often think of them as solitary entities, they can indeed be part of binary or even trinary systems, where 2 or 3 stars orbit each other. Such configurations can lead to complex gravitational interactions, influencing the orbits and climates of any planets within these systems. Here's something to ponder. The slow-burning nature of red dwarfs means that they will outlast all other types of stars. As our universe ages, these stars will continue to shine while others fade away. In the far future, when galaxies have drifted apart and the cosmos becomes a colder, darker place, red dwarfs will remain as steadfast beacons of light and heat. As we marvel at the endurance of red dwarfs, it's worth noting that they can also exhibit a form of stellar evolution known as flare stars. These stars experience sudden increases in brightness due to magnetic activity. Despite this variability, they remain remarkably stable over long periods, maintaining their gentle glow long after other stars have exhausted their fuel. And consider this. The proximity of planets to their red dwarf hosts means that they could experience tidal locking, as we've mentioned before. But what's truly captivating is the possibility of distinct atmospheric patterns emerging on these planets. As the atmosphere circulates between the day and night sides, complex weather systems could arise, potentially creating rich environments for life to develop. In addition to fostering unique weather patterns, the magnetic fields of red dwarf stars can also give rise to spectacular auroras on orbiting planets. These natural light displays, driven by stellar wind interactions, could provide stunning vistas for any inhabitants fortunate enough to witness them. Lastly, let's not forget about the potential for life beneath the surface of planets and moons in red dwarf systems. Even if the surface conditions are harsh, subsurface oceans, heated by geothermal energy or tidal forces, could offer sanctuary for life. Such environments might be the most promising places to search for extraterrestrial organisms hidden from the harsh radiation of their star. Isn't it remarkable how much potential and mystery lies within these seemingly modest stars? As we continue to explore the universe, red dwarfs will remain a focal point of our quest to understand the cosmos and our place within it. With their longevity, stability, and abundance, they offer countless opportunities for discovery and wonder. Let me share something fascinating about red dwarf stars. While they are known for their longevity, their slow-burning process means that they never reach the dramatic end stages of life that larger stars do. Unlike massive stars that explode as supernovae, red dwarfs quietly fade away, slowly transitioning into white dwarfs. It's a peaceful conclusion to a long life, one that might make you appreciate their gentle nature even more. Now, have you ever wondered about the colors of the planets orbiting these stars? Because red dwarfs emit light mostly in the red and infrared spectrum, any life that does develop on nearby planets might perceive colors very differently than we do. Imagine a world where the lush greens of a forest are muted, replaced by hues we can only dream of. It's a reminder that the universe can be a place of endless variety. Here's another intriguing detail. Red dwarf stars, despite their name, can sometimes appear more orange or pink, depending on how much dust and gas lie between them and Earth. This cosmic haze can scatter and alter the star's appearance, making observations even more enchanting. In some ways, it's like the universe is painting its own masterpiece, with red dwarfs as its delicate brushstrokes. Speaking of appearance, the small size of red dwarfs can also make them difficult to detect. Though they are the most common type of star in the galaxy, their faint glow means that many remain hidden from our view. The fact that we are constantly discovering new ones is a testament to the vastness of space and the advances in our observational technology. Can you imagine a world where the night sky is dominated not by a bright moon, but by a dim red dwarf? For planets orbiting these stars, such a sight would be the norm, with the soft, steady glow providing an ever-present backdrop to their celestial dance. It's a humbling thought to realize how varied the night skies can be across the universe. And here's something you might find surprising. The flares from active red dwarfs can be so intense that they might strip away the atmospheres of nearby planets. Yet, these same powerful bursts also release ultraviolet light, which can break apart molecules and potentially kickstart the chemical reactions needed for life. It's a delicate balance of destruction and creation, a cosmic dance that shapes the destiny of worlds. On the topic of creation, did you know that red dwarfs are typically formed in clusters? These stellar nurseries are bustling with activity, with dense clouds of gas and dust collapsing under gravity to birth new stars. The sight of a red dwarf emerging from its cocoon is a reminder of the continuous cycle of life that pervades the universe. Another curiosity is that red dwarfs can be surprisingly magnetic. Their magnetic fields are much stronger than those of larger stars, and this intense magnetism can cause spots akin to sunspots on their surfaces. These spots can be enormous, sometimes covering significant portions of the star and affecting its brightness. It's fascinating to think of these stars as being sprinkled with cosmic freckles. Have you ever pondered the relationship between red dwarfs and their planets' climates? Close orbits mean that planets could experience extreme climate variations, with one side facing perpetual daylight while the other is locked in an endless night. This dichotomy could generate fierce storms along the Terminator line, the boundary where day meets night, fueling dynamic and potentially habitable environments. Here's a thought-provoking fact. Because red dwarfs are so common, they might outshine the Milky Way's more luminous but rarer stars in terms of potential habitability research. If we are ever to find twin Earths in distant planets, chances are high that they orbit one of these steadfast stars. It's a promising prospect that keeps astronomers tirelessly scanning the cosmos. Speaking of scanning, the search for planets orbiting red dwarfs has been revolutionized by transit photometry, a technique that detects the slight dimming of a star as a planet passes in front of it. This method has unveiled a treasure trove of exoplanets and continues to be a cornerstone of planetary science. Each new discovery is a step closer to answering the age-old question of whether we are alone in the universe. And here's a delightful tidbit. The gravitational pull between a red dwarf and its close-orbiting planets can be so strong that the planets are tidally locked. This means that one side of the planet always faces the star, while the other side remains in darkness. It's a fascinating setup that could lead to diverse ecosystems thriving under different conditions on the same planet. Lastly, consider the idea that red dwarfs might play a vital role in the future of human exploration. As we venture further into space, these stars could become waypoints or even homes for future generations. Their longevity ensures a consistent source of energy over unimaginable timescales, providing a beacon for our journey through the cosmos. Isn't it remarkable to think about the hidden treasures that lie within these modest stars? As we continue to gaze into the night sky, red dwarfs remind us of the universe's enduring mysteries and the endless opportunities for discovery they hold. With each passing day, our understanding of these stellar wonders deepens, bringing us closer to unveiling the secrets of the cosmos. Did you know that red dwarfs have a tendency to live extraordinarily long lives? In fact, these stars can burn for tens to hundreds of billions of years, far longer than our Sun. Their slow and steady fusion process means they sip on their hydrogen fuel with remarkable efficiency. This longevity makes them the Methuselahs of the stellar world, providing a continuous glow long after other stars have faded from existence. It's comforting to think that under their watchful eye, countless worlds have the potential to evolve in their own unique ways. And speaking of evolution, did you know that planets orbiting red dwarfs might have to develop special adaptations due to the star's unique emissions? These stars often emit strong flares of radiation, which could be harmful to life as we know it. Imagine a world where organisms have evolved protective mechanisms to shield themselves from this cosmic weather. It's like nature's own form of innovation, driven by the challenges presented by their stellar neighbors. Here's an intriguing thought. The zones where life might flourish around a red dwarf are much narrower compared to those around larger stars. This is known as the habitable zone or the Goldilocks zone, where conditions could be just right for liquid water to exist. Because red dwarfs are cooler, their habitable zones are closer in, meaning planets need to be snugly tucked in to potentially support life. It's like finding the perfect cozy spot near a campfire, warm enough to be comfortable, but not so close as to get burned. Another fascinating aspect of red dwarfs is their ability to retain a sort of eternal youthfulness. While larger stars go through dramatic changes as they age, red dwarfs remain relatively constant throughout their lifetimes. They don't balloon into red giants like our Sun will one day. Instead, they quietly continue their fusion cycle, barely changing over billions of years. This stability is a reassuring quality for any potential life forms relying on their light and heat. Have you ever wondered how scientists can tell so much about a star from light years away? A captivating method used involves studying the light emitted by these stars. By analyzing the spectral lines, scientists can determine the star's composition, temperature, and even movement. It's like reading a cosmic fingerprint, unveiling secrets written across the vastness of space. With red dwarfs, this task is a bit trickier due to their dimness, but advances in technology continue to improve our ability to understand them. Now, let's consider the fascinating idea of stellar companionship. Red dwarfs are often found in binary systems, paired with another star. This companionship can influence the development of planets within these systems, potentially leading to diverse environmental conditions. Imagine the night sky on such a world, with two stars casting their combined glow creating surreal landscapes bathed in mixed light. Such a dual star system would be a wonder to behold. On the topic of star companions, it's interesting to note that red dwarfs can sometimes pull material from their partners in these binary systems. This process, known as accretion, can lead to the red dwarf brightening temporarily as it burns the acquired material. It's a celestial dance of give and take, where even the smallest of stars can briefly shine brighter, altering the dynamics of their stellar relationship. Speaking of dynamics, did you know that red dwarfs are often much more active than larger stars like our Sun? They exhibit frequent magnetic activity, which can influence the space weather around them. This activity can also affect any orbiting planets, potentially impacting their atmospheres and surface conditions. It's a reminder that even the smallest stars can exert significant influence over their surroundings, shaping the environments of distant worlds. Here's a curious fact. Despite their abundance, red dwarfs were not discovered until relatively recently in the grand scheme of astronomy. Their faint nature made them difficult to spot with early telescopes. It wasn't until the development of more advanced observational tools that we began to appreciate just how numerous these stars are. This hidden majority challenges our perception of the universe, offering insights into the unseen forces that shape the cosmos. Can you imagine a galaxy where red dwarfs were more visible than the brighter stars we typically notice? With their vast numbers, if they emitted more light, our night skies might look entirely different. It's a humbling thought, realizing that the universe holds so much more than what we can perceive with the naked eye. One more thing to consider is the potential for diverse planetary systems around red dwarfs. Their long lifespans mean they have plenty of time to gather and nurture a variety of planets. Each system could be a treasure trove of unique worlds, each with its own story to tell. As we continue to explore and search for exoplanets, red dwarf systems remain some of the most promising candidates for finding life beyond our solar system. The universe is a vast and wondrous place, full of surprises and discoveries waiting to be made. Red dwarfs, with their quiet yet enduring presence, remind us that even the smallest stars can hold the most profound mysteries. As we drift off to sleep, it's comforting to think of these gentle cosmic sentinels, lighting the way for new chapters of exploration and understanding. Let me share a little-known fact about red dwarf stars. Despite their diminutive size and faint glow, they may have a profound influence on the cosmic balance. It's fascinating to think about how these seemingly inconspicuous stars make up a significant percentage of the stellar population in our galaxy. In fact, red dwarfs account for a staggering 70 to 80% of the stars in the Milky Way. Picture that for a moment. A galaxy teeming with these quiet giants, subtly shaping the cosmic environment around them. And here's something intriguing. Red dwarfs are highly efficient with their fuel consumption. While larger stars burn through their hydrogen at a rapid pace, red dwarfs use theirs so gradually that they can continue shining for tens of billions of years. This slow-burning nature means they could outlast the universe as we currently understand it, witnessing the unfolding of cosmic history far beyond our own existence. Speaking of longevity, did you know that their extended lifespan might offer unique opportunities for the emergence and evolution of life? The stability of red dwarfs over such long durations provides a consistent energy source, which could be crucial for life to develop and thrive on surrounding planets. Imagine the possibility of civilizations that have had billions of years to advance, evolving under the steady gaze of their red dwarf sun. Here's a captivating thought. Red dwarfs might host planets with atmospheres vastly different from what we find around our sun. The intense magnetic activity of these stars can strip away atmospheres or alter their compositions, creating conditions we might not even imagine. This could lead to a variety of atmospheric chemistries and surface environments, each one potentially harboring life forms suited to these unique circumstances. Speaking of planets, it turns out that many of the exoplanets discovered in recent years orbit red dwarfs. This is partly because their habitable zones are so close in, making it easier for our instruments to detect them. With advances in technology, we've begun to unveil a whole universe of planets that offer tantalizing glimpses into unknown worlds. Just think of how much more we have yet to learn about these distant neighbors. Have you ever considered the implications of a red dwarf's flaring activity on habitability? These frequent and often intense flares can bathe nearby planets in high-energy radiation, potentially stripping away atmospheres or making surfaces uninhabitable. Yet, it's possible that life could adapt to such conditions, perhaps developing underground or beneath protective layers. It's a testament to the resilience of life, finding ways to endure even in the face of harsh cosmic forces. Here's an intriguing fact. Red dwarfs can exhibit a wide range of temperatures. While they are generally cooler than larger stars, Individual red dwarfs can differ significantly in their thermal properties. This diversity can lead to a variety of habitable zones and planetary environments, each with its own potential for supporting life. It's like a cosmic puzzle, with each piece offering a new possibility for discovery. And did you know that red dwarfs might play a crucial role in the galactic ecosystem by enriching the interstellar medium with heavier elements? As they age, some red dwarfs end their lives by shedding their outer layers, contributing to the cosmic material that eventually forms new stars and planets. This recycling process is essential for the evolution of galaxies and the creation of diverse planetary systems. Let me share another fascinating aspect of red dwarfs: their varied rotational velocities. Some spin slowly, taking weeks or even months to complete a rotation, while others spin much faster. This rotation affects the magnetic fields of red dwarfs, influencing their flare activity and, by extension, the environments of any orbiting planets. It's a delicate dance of forces that can have far-reaching implications for potential habitability. The concept of tidal locking is another intriguing consideration when it comes to planets orbiting red dwarfs. Because these planets are often so close to their star, they might become tidally locked, with one side perpetually facing the star and the other in constant darkness. This could create stark temperature differences, leading to unique weather patterns and climate dynamics unlike anything we experience on Earth. Imagine a world where red dwarfs were the only stars in the galaxy. Their subtle light would transform the night skies into a mysterious tapestry of faint glows, each one a silent witness to the universe's unfolding story. Such a galaxy would be a place of quiet endurance, where cosmic events unfold at a pace governed by the slow rhythms of these tiny yet significant stars. As we ponder the hidden wonders of red dwarf systems, it's astonishing to think about how much more there is to discover. Each new observation brings us closer to understanding the fundamental forces that shape our universe. Red dwarfs, with their gentle yet enduring presence, offer a window into the mysteries of the cosmos. As you drift into slumber, let your mind explore the possibilities these stars present and dream of the endless potential that lies among the stars. Let me take you on a gentle journey through some surprising wonders about red dwarf star systems. Have you ever wondered about the colors of the skies on planets orbiting these stars? Unlike our sun's yellow light, a red dwarf's cooler red-tinted glow might paint skies in shades of orange or even deep crimson. Such a landscape would be breathtaking, casting everything in a warm, otherworldly hue. Imagine the impact of this red light on plant life. If plants evolved on such planets, they might not be green, as we know them, but perhaps deep purples or even black. This adaptation would allow them to absorb the scarce light more efficiently. Isn't it fascinating how life could adapt in ways we can scarcely comprehend? Speaking of adaptations, did you know that a planet in a red dwarf system might develop unique geophysical features due to the gravitational pull of its star? The intense gravitational forces could lead to volcanic activity or even tidal heating, where the core of the planet remains warm due to the constant gravitational flexing. Such conditions could create vast underground oceans hidden beneath icy crusts, providing a potential haven for life. We often think of space as silent and serene, but red dwarfs can be surprisingly noisy. Their magnetic activities can create bursts of radio waves, which, if we could hear them, would be a cacophony of cosmic sound. Imagine tuning into the symphony of the universe, where every star has its own melody. Here's something to ponder. The majority of known multi-planet systems orbit red dwarfs. This high occurrence is likely due to the compact nature of these systems, where planets can form and thrive in close proximity to their star. It's as if red dwarfs are nurturing families of planets, each one spinning through the darkness in a cosmic ballet. You might be surprised to learn that the earliest stars in the universe could have been red dwarfs. These primordial stars, born of the universe's first elements, might still be burning today, their ancient light reaching us across the eons. This enduring presence suggests that red dwarfs are not just ubiquitous in our galaxy, but potentially the first to illuminate the cosmos. While red dwarfs may seem like steady, unchanging beacons, some harbor a secret. They can evolve into white dwarfs, shedding their outer layers and leaving behind a dense, hot core. This process, though rare, adds another layer to the life story of these stars, demonstrating their dynamic and ever-evolving nature. Imagine the potential for auroras on planets orbiting red dwarfs. The interaction between stellar winds and a planet's magnetic field could produce spectacular displays, bathing the skies in shimmering, colorful lights. These natural wonders remind us of the beauty and complexity inherent in the universe. Have you considered the notion that red dwarf stars could act as cosmic lighthouses for navigation? In a universe teeming with these stars, their prevalence and predictability might one day serve as guides for spacecraft, charting paths across the vastness of space with their steady, persistent glow. Consider the idea that red dwarfs could host rogue planets, worlds that wander through the galaxy untethered to any star. When passing near a red dwarf, these planets might be captured by its gravity, finding a new home and potential warmth. It's a cosmic game of chance, where the vast distances of space occasionally bring wandering worlds into the embrace of a stellar companion. Did you ever think about the role of red dwarfs in our search for extraterrestrial intelligence? Their long lifespans provide stable conditions for civilizations to emerge and evolve, potentially making red dwarf systems an ideal target for listening for signals from distant advanced societies. Here's a curious thought. The planets around red dwarfs might have atmospheres rich in exotic compounds shaped by the stellar winds and radiation of their sun. These atmospheres could contain gases like methane or ammonia, creating conditions vastly different from Earth but still conducive to life. The gravitational pull of red dwarfs can also affect their planets in intriguing ways, causing the crust to flex and crack, leading to tectonic activity. This geological dynamism can create diverse terrains, from towering mountains to deep chasms, fostering a rich tapestry of environments. Let me share one more intriguing aspect. Some red dwarfs are so faint that despite being relatively close to us, they were only discovered in recent decades. Their elusive nature highlights how much we still have to learn and discover, even in our own cosmic neighborhood. As you drift further into the comforting embrace of sleep, imagine the myriad of possibilities these stars hold. Their quiet presence is a reminder of the intricate and wondrous tapestry of the universe. Red dwarfs, with their subtle beauty and complexity, continue to captivate our imaginations, inviting us to explore, learn, and dream of the infinite stories written in the stars. Have you ever imagined how the slow-burning nature of red dwarfs might affect the planets within their grasp? Because these stars have such extended lifespans, their planets have billions of years to evolve and develop. This longevity allows for unprecedented stability, making red dwarf systems prime candidates for the eventual emergence of life. This constant, gentle glow is one of the reasons astrobiologists often turn their gaze to these stars when considering the potential for habitable worlds. Here's something intriguing. Red dwarf stars can have highly complex magnetic fields. These magnetic structures are not only responsible for the star's flaring activity, but also play a role in shaping the space environment of their planets. The magnetic interactions can lead to the formation of radiation belts around these planets, much like Jupiter's intense belts, which might influence the surface conditions and evolution of planetary atmospheres. It's fascinating to consider how the formation of red dwarf systems might differ from that of other types of stars. Some scientists propose that these stars could form from turbulent, chaotic regions of gas and dust, environments that might discourage the formation of larger stars. This could explain why red dwarfs are so prevalent in the universe, acting as the workhorses of star formation, quietly assembling while more massive stars burn brightly and briefly. Speaking of formation, did you know that red dwarfs often host planets with tightly packed orbits? These compact systems can lead to intriguing gravitational interactions between the planets themselves. These gravitational dances can result in orbital resonances, where the planets' orbits sync in a harmonious rhythm, stabilizing their paths and potentially influencing their habitability. A surprising thought is that red dwarfs can be remarkably efficient at recycling material. When a red dwarf ages and eventually transforms, it can release material back into the surrounding space. This matter can then be incorporated into new star systems, continuing the cycle of cosmic creation. It's a testament to the interconnectedness of the universe, where nothing is wasted and everything contributes to the grand tapestry. You might find it curious that some red dwarf systems could harbor planets with atmospheres that produce misty, cloudy conditions. The cooler temperatures of these stars, combined with specific atmospheric compositions, could lead to clouds of exotic compounds, casting alien skies into a mysterious haze. Imagine, if you will, a world where the sky is not blue, but a swirling, ethereal blend of colors, constantly shifting with the winds. Red dwarfs are also known for their unpredictable temperaments. While generally stable, they can experience intense periods of stellar flaring, where bursts of energy erupt from their surfaces. These flares can dramatically affect the climates on surrounding planets, temporarily altering atmospheric conditions and even stripping away portions of an atmosphere, depending on its strength. It's a reminder of the raw power and unpredictability inherent in these otherwise modest stars. Consider the possibility that planets orbiting red dwarfs could have unusual day-night cycles. Some of these planets might be tidally locked, with one side always facing their star while the other remains in perpetual darkness. This could lead to extreme climate differences between the two hemispheres, creating a world of stark contrasts, where the line between day and night becomes a region of perpetual twilight and possibly the most hospitable area for life. Here's a thought-provoking idea. Red dwarf stars, with their cooler temperatures, might influence the type of chemistry that occurs on their planets. The reduced energy from the star could favor slower chemical reactions, potentially leading to the development of life forms that are fundamentally different from anything we know. Wouldn't it be fascinating to discover organisms that thrive in such unique environments, perhaps utilizing biochemical processes we've never imagined? Another enchanting aspect of red dwarfs is their potential to host planets with water in unexpected forms. In the cold outer regions of these systems, water ice could dominate, creating worlds of frozen expanses. Meanwhile, closer planets might harbor liquid water beneath thick atmospheres or surface ice, sustained by geothermal heat. The variety of water states across these systems underscores the diversity and adaptability of conditions that might support life. Imagine the potential for planets around red dwarfs to experience prolonged seasons. Due to the gravitational influences of other planets or the star itself, these worlds might have tilts that result in extended seasons, with long, slow transitions between them. This could allow life on these planets to adapt and thrive in ways that are uniquely attuned to such gradual changes. Did you know that red dwarfs, despite their name, can actually vary widely in color? Depending on their temperature and age, they might appear not just red, but also orange or yellowish. This subtle spectrum of hues adds another dimension to their character, painting the cosmos with a richness that defies their simplistic moniker. Lastly, consider the legacy of red dwarfs in the cosmic timeline. As some of the longest living stars, they will outlast many of the larger, more luminous stars, continuing to shine when other stars have long faded. This enduring presence ensures that even as the universe ages, there will still be light, a gentle reminder of the perpetual nature of existence. As you let these sleepy facts about red dwarf star systems guide you toward rest, imagine the boundless possibilities these stars hold. Their serene yet complex nature invites us to dream of the countless stories they have to tell, each one a whisper in the vast starry night. Did you ever wonder how the magnetic fields of red dwarf stars can impact their planets? These fields are often strong and complex, capable of influencing the magnetic environments of their planets. A fascinating result of this is the creation of auroras, not unlike those on Earth, but potentially much more vibrant and widespread. Imagine an entire planet bathed in the gentle glow of auroras, lighting up the night sky in colors beyond our earthly spectrum. Speaking of colors, have you considered how the light from a red dwarf might affect the evolution of plant life? On a planet orbiting such a star, plants might evolve to harness the red and infrared energy more effectively. This could lead to foliage not in the green spectrum we're accustomed to, but perhaps in shades of black or deep purple, optimizing photosynthesis under these unique conditions. Can you picture a forest painted in these striking hues? Another intriguing aspect is the longevity of red dwarfs. Unlike our Sun, they burn their fuel much more slowly, allowing them to shine for potentially trillions of years. This astonishing lifespan provides a stable environment for planets to orbit, possibly giving rise to life that has time to evolve and adapt in extraordinary ways. It's a gentle reminder of the persistence and resilience found in the cosmos. Let's talk about the density of red dwarf systems. Since these stars often have planets with close orbits, their planetary systems can be tightly packed. This close proximity could lead to frequent planetary transits, where planets pass in front of their star from our viewpoint. These transits are a valuable tool for astronomers studying the composition and atmospheres of distant worlds, offering windows into their mysterious realms. Did you know that some red dwarfs can form in binary or even multiple star systems? These complex gravitational dances can lead to fascinating orbital interactions, where planets may orbit around multiple stars, experiencing shifting patterns of light and shadow. Such dynamic systems challenge our understanding of planetary stability and habitability, painting a picture of a universe filled with possibilities. When we consider the habitability of planets around red dwarfs, we must also think about their radiation environments. Despite their diminutive size, red dwarfs can emit significant amounts of radiation, especially during flares. This radiation can strip away planetary atmospheres over time, creating a delicate balance between a planet's ability to retain its atmospheres. Let's explore another captivating idea: the potential for moons around planets in red dwarf systems to harbor life. These moons, warmed by tidal forces or atmospheric conditions, might offer refuge for life even if the parent planet is inhospitable. This expands the potential habitats in red dwarf systems, suggesting that life could emerge in places we might not traditionally expect. Have you ever imagined what it would be like to visit a planet orbiting a red dwarf? The landscapes might be shaped not just by the usual geological processes we're familiar with, but also by the star's unique characteristics. Frequent flares could lead to dramatic surface changes, while the dim but steady light might create a world of subtle contrasts and shadowy vistas, inviting exploration and discovery. Here's a thought about the birth of red dwarf stars themselves. These stars formed from collapsing clouds of gas and dust, a process that can take millions of years. During their formation, they gather material from their surroundings, growing slowly and steadily. This patient process contrasts with the more violent births of larger stars, highlighting the gentle beginnings that lead to their long lives. Another surprising fact is how red dwarfs can vary in activity levels over their lifetimes. Some young red dwarfs can be exceptionally active, with frequent and powerful flares, while older ones may settle into quieter phases. This variability adds a layer of complexity to understanding the environments of their orbiting planets, as the changing activity levels could significantly impact climate and habitability over time. Consider the role of red dwarfs in galactic ecology. These stars are numerous and long-lived, serving as cosmic anchors that shape the dynamics of galaxies. They contribute to the recycling of material within galaxies, playing a pivotal role in the ongoing cycle of star formation and death. In this way, red dwarfs are fundamental to the balance and evolution of the universe at large. Did you know that the atmospheres of some red dwarfs can be surprisingly dynamic? These stars can exhibit atmospheric phenomena like sunspots and prominences, which can influence the star's magnetic activity and the surrounding space weather. The study of these features not only enhances our understanding of red dwarfs, but also offers insights into the broader processes at play in our galaxy. As you ponder the wonders of red dwarf star systems, imagine the untold stories they hold. With their stable, enduring light and the diverse worlds they nurture, these stars weave intricate tales across the cosmos. Each fact we've explored adds another thread to this rich tapestry, inviting us to look deeper, to wonder, and to dream about the endless possibilities that await in the vastness of space. Let the calm and persistent glow of red dwarfs guide your thoughts as you drift gently into the realms of sleep, where the universe continues its eternal dance.